Hello, welcome to this e-training module looking at a basic pan sharpening technique implemented using the Spatial Model editor and using some of the band math capabilities that are inherent in the Spatial Modeler. Erdas Imagine already has several state-of-the-art pan sharpening tools built in, but sometimes you want to just go ahead and try things or learn how to use the capabilities that are in the Spatial Modeler that relate to that type of image processing algorithm implementation. So we're going to use this data set that you're seeing on screen, which is some QuickBird 2 data courtesy Digital Globe. On the left hand view you can see some high resolution panchromatic imagery, and on the right hand view you can see the corresponding lower resolution multispectral. And obviously the traditional pan sharpening desire is to get the best of both worlds, have the fine detail that you can see in the pan imagery, but have the colours inherent from the 4-band or however many band it may happen to be lower resolution multispectral data, so high resolution multispectral information. So that's what we're going to do in this particular e-training video. So let's go ahead and start Spatial Model Editor, which we do today. I think I'll use my shortcut that I've added to my quick access toolbar up at the top. Just click on that button and I start in Use Spatial Model Editor. And I'm going to show you another quick trick, which is if you already have the data that you're interested in processing or developing your algorithm using as a test bed, you can just drag and drop from the table of contents onto the Spatial Model Editor to add those data sets as raster inputs, predefined raster input objects in Spatial Modeler. Then let's go ahead and get rid of those views just so we can see our canvas more clearly. Just a quick, easy way of getting them in there rather than using the raster input dragged from the operators listing. One thing we do want to do, however, is define some additional parameters on these input rasters. The top one is the panchromatic, so I'm going to go ahead and double click on that particular operator, bring up its raster input dialog. Now, because we are going to be doing some band math operations, which might include multiplication, division, and so on, we do want to evaluate those mathematical functions in floating point accuracy, not in integer. My inputs here are unsigned 16-bit integer data sets coming from QuickBird 2 imagery. So if I don't change the declarations of the calculations, they may well get performed in the native type, which is integer. The easiest way to set this then is to do so on the raster input. So just declare that input, even though it is stored as unsigned 16-bit, we can come in and say read as float. So the data set is being declared as a floating point data set. We might also want to set an interpolation. Now the panchromatic, we're going to do the pan sharpening to the resolution of the panchromatic data, so we really don't want it being resampled in any manner when we're going out to the output file, so we're going to set it to nearest neighbor just to make sure, and then click OK. So then go back to the multispectral input image, double click it to look at its raster and input. Again, we can declare it as float because we've declared one input. It'll generally, if we're multiplying two inputs from the two separate sources, it would default to the highest data type, but you might just do a band math on just the multispectral. So we'll declare it as float as well, but more importantly, you do want to have an interpolation method on the multispectral because it's being resampled to the pixel size, or the processing is happening resampled to the pixel size of the panchromatic data. So we're going to go ahead, I'll pick a bilinear interpolation, might want to use a Lagrange or something else for higher accuracy, but we're good enough with bilinear interpolation for this particular method. Click OK, and we've defined that. So now to get into the actual interesting stuff of performing our calculations. What we're going to do is apply a filtering function to the panchromatic. So for that we need a moving window definition, a kernel definition. So we're going to use the kernel matrix input, drag and drop that onto our canvas, double click it. We're going to start off, I'm going to click from library, and we're going to pick the 7x7 low pass, which is just a 7x7 matrix filled with ones to define the moving window. And then we're going to convolve or filter the panchromatic data using that particular kernel. So we're going to add a convolve, a matrix convolution, or a matrix multiplication function into our model. Has a raster in. We're going to feed in the panchromatic and feed in that matrix. And then what we will want to do is actually divide the original panchromatic data by the smoothed version of the panchromatic data. So look for the divide math function, bring that in, drop it in. So we're going to take the original pan and divide it by the smoothed pan, which effectively will sharpen the pan. And then obviously we need to introduce our multispectral data. So just as a very basic sharpening approach, we're going to take that enhanced pan and just multiply it through each of the 4 multispectral bands. Let's just go ahead and look at that. I'm going to drop in a preview operator, connect that up to our pan sharpened data set, and by default the Spatial Modeler is going to operate at the defined processing area is basically going to default to the highest resolution input of any, if there's multiple raster inputs with differing pixel sizes, it's going to default to the highest resolution, which will be the pan. That's why I don't need to do anything else at this particular stage to set that. Let's go ahead and click preview, and then in real time we get a pan sharpened version of our data set. So if you remember this particular area at the beginning of the video, the multispectral, you didn't see any of the fine detail in these parking lots now in the multispectral imagery, but now you can actually go ahead and see that. And one thing we might want to play with is the matrix settings. So rather than a 7x7, if I come into the properties down here at lower right and actually say apply a 3x3 smoothing, you actually see the difference immediately as the data is processed, as the band math is applied in real time. So it's not as sharpened as it is using the 7x7 low pass. Set it back to 7x7 and you see the increase in spatial resolution. So there we have the basic pan sharpening being applied through band math operations within the Spatial Modeler to produce real-time visualization of that processed data. As with all of these things, rather than a preview, we might actually want to write out a data set. Let's turn the preview off so we can easily drag in a raster output operator, connect up my port from the multiply, double click file name, give it a name, and then we could process that to disk simply by clicking the run button. We will go ahead and do a file, save as, spatial model as. We'll call this pan sharpen, so we can reuse this model with other inputs rather than having to keep constructing the model over and over again. And we can go ahead and do that. As I mentioned earlier, you might want additional control over the processing area parameters and other parameters of how the data sets are interpreted within your spatial model. So let's go ahead, I'll just quickly show you that. If we look for the define processing area operator, we drag that in, and I'm going to disconnect. Let's move these over, box select them and drag them over, and I'm going to connect up these 2 inputs instead to the define processing area operator. If we go ahead and double click this, we have various options that we can set. We can set the grid rule. The grid rule is going to be by default defined by the cell size rule and the window rule below. And as I mentioned earlier, that's defaulting to the minimum of the inputs, the intersection of the 2 inputs if they have different extents. You could even change the projection system. So in this instance, the input data is in lat long, but I might want my pan sharpened data to be in UTM. and I could go ahead and set that as the processing rule on the spatial model as the data is pulled through this particular operator. Just as an example though, what I'm going to do here is set a window rule with the specify option, and I'm going to go ahead and specify some parameters. I could use the inquire box to set my extent. I'm going to go ahead and type those parameters in as I already have them defined. And lower right is 34.2 degrees. So we've just set a geographical extent to use. Click OK. You can see the parameters are reflected on the input ports. Going ahead and hook my outputs. So basically this defined processing area is taking in the two raster streams, defining the common processing area parameters, and then sending those two streams out with those two raster streams now set to this definition. So they just get multiplied again and sent out. We go ahead and preview again. Now you'll see different upper left corner because I've constrained my processing to a particular area. Now only that area is being sent through the pan sharpening. So there we go. Let's go ahead, move that over, and click save on my spatial model again. I could go ahead and produce the raster output if I wished. Let's go ahead and do that whilst I'm talking. So it's now going ahead and writing out a file, so if I want to give that to other people to use rather than previewing on the fly, it will be produced as a pan sharpened output image with the parameters that I've defined in this spatial model. So you can see how easy it is to go ahead and start to do quite complex band math operations. In this instance I've been doing band math pulling in from multiple input raster datasets. Could be from a single raster dataset with multiple bands that I wish to say do indices and so on. Perfectly quick and easy to do using Spatial Modeler. So thank you very much for watching. So that actually concludes all the training modules in the Introduction to Spatial Modeler course. It's been made up of several different e-training module videos. There are other videos out there though. If you want to review some more spatial models looking at pan sharpening, I would recommend this one on the NN diffuse algorithm. Just go ahead and search on that title or follow the link. And there are other spatial modeler based e-training videos out there, so please look them up on our website, and hope you enjoy watching some more and have enjoyed this particular course. Thank you very much, and please stay safe.